Good morning students. Today we are going to take the practical application of Newton's second law of motion. Now we have studied earlier in this that the Newton's second law of motion states that the rate of change of momentum is directly proportional to the applied force in the direction of force. And the mathematical formulation of Newton's second law of motion is F is equals to ma or F equals to mv minus u upon t. Now today we are taking the practical application of Newton's second law of motion. You might have seen that when a cricket player catches the ball, he pull his hand backward. He pull his hand backward. Now why he is doing so? He is doing so because he pulls his hands backward to increase the time. Of reducing the high velocity of the ball to 0. So it will increases the time, and due to increase in the time, the acceleration, that is v minus u upon t, this will become less. And since the acceleration is less, so the force will be less force is applied to stop the ball. So that means less force will be applied on the hand, and that's why there will be less impact on hand and he will not get injured. Let us suppose he does not do in this manner. So in that case, what will happen is, if he holds the catch like this, then the time will be a very short period of time. Since time will be very less, so the acceleration will become high. This is v minus u upon t. If the time is very less, the acceleration will become high, and due to the high acceleration, more force will be required to stop the ball, and it will cause injury on his hand. Now let us take the second example of high jump. We might have seen that in when we do the sports activity, the high jumper falls on the cushion bed. Why he falls on the cushion bed? This is again the same. It also applies the practical application of Newton's second law. A high jumper, when falls on a cushion bed, and the high velocity of the athlete reduced to 0 and the time is increased. So when he falls on the cushion bed, the time is increased. So due to that, less rate of change of momentum is there, and since less rate of change of momentum is there, force will be less force on athlete will cause lesser injury. So these are the practical application of Newton's second law of motion. Now let us see how the Newton's first law of motion is a special case of Newton's second law of motion. Now first we should know what is Newton's first law of motion. Every object try to remain in state of rest or in uniform motion in a straight line unless compelled by an external force on it. Now see, according to Newton's second law of motion, we will derive the Newton's first law of motion by using Newton's second law of motion. We know that Newton's second law says that F is equals to ma, that is F is equals to m v minus u upon t. Now let us say there is no external force acting on an object. There is no external force acting on an object. In that case, the force will become 0, and that is m v minus u upon t. Do cross multiplication, 0 into t upon m is equals to v minus u, and when multiplied by anything by 0 will remain 0. So 0 is equals to v minus u. So u will be equals to v. Now you can see that the initial velocity, in the absence of any external force, unbalanced external force, you can see that we have derived that u and v are equal. That means if an object is at rest, that means if the initial velocity is 0, the final velocity will also remain 0. That means if object is at rest, so it will remain at rest. And the second thing is that if an object is, let's say, object is moving with initial velocity of 5 meter per second. So if u is 5, so v will also become 5. So that means it is moving with the same velocity, that is the uniform velocity. So this proves that this Newton's second law of motion proves that the Newton's first law of motion is a special case of Newton's second law of motion,